Hi guys, am I audible?
Yes, ma'am, you are.
Yes, ma'am. Good evening, ma'am.
Yes, ma'am.
Good evening. Good evening. We'll just wait 2-3 minutes. Let everyone join, then we'll just start off. Fine?
Okay, ma'am.
Okay, ma'am.
Yeah. Okay. Okay, guys, let's just start. So let me just open my word. My voice is audible to you, right? It is proper. Like you are able to hear me
Yes, ma'am.
properly.
Yes,
Yes,
ma'am. It
Oh,
is
Yes,
ma'am.
ma'am.
proper.
Yes,
Yes,
ma'am.
Yes,
ma'am. It
ma'am.
is. Yes, ma'am.
okay, fine.
Yes, ma'am.
Okay, okay, thank you. So let me just open my word and just share the screen. Screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So first, since yesterday we have done with like K means in details, uh, like in the mathematical format how K means actually works. We have already seen it. So we'll today we'll go ahead and do the formation like the coding for K means, and before that we'll go ahead and understand about elbow method, right? So, first, tell me what is elbow method? I guess some of you have implemented K means with elbow method. So, tell me what elbow method is actually, right? No one? Am I not audible or anything like that?
Ma'am, you
You're
are
audible,
audible.
ma'am.
Okay, then tell me about elbow method. Some of you have implemented, right? If you don't want to, that is also fine. Not an issue. Just let me know.
Don't know, ma'am.
Okay, fine, great. So what elbow method is, we'll be discussing in details and eventually we'll try to plot it as well. Fine. So what is elbow method? So elbow method, we can think it of as a simple way by which we can find the best number of clusters. So you remember in KNN what we were, sorry, K means what we are doing, we are taking the value of k. Hopefully, like yesterday, the details what I have like write it down in this word. Somehow I forgot to save. That's why the details are not here. But hopefully you remember that we get the values of k, and initially what we are doing, we are estimating the value of k, right? So yesterday's problem, I guess we have taken the value of k to be 2, and from there we have taken the value like the centroid, two specific centroid we have taken into count. We have calculated the Euclidean distance, and based on that taken the average of the points, and based on that we got the new centroid, right? So for that we have taken the value of k, right guys?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So what actually we are doing, what k is? K is the number of clusters. K is number of clusters, right? So in this case, what actually we are doing with elbow method is a form or a way by which we find the best number of clusters. So we have taken like for that much data that we have taken into consideration, like we have at least four data that we have taken yesterday, right? And based on that, we have taken k value to be two, right? Now like we in some of the problems where we are get across like huge number of data, suppose the data is around the data set, the row is that we are getting, row value that we are getting, that is suppose around 2000 or 20,000 we can say. Okay, so from that very data, it is very impossible or exact measure of what might be our k value. To determine that, that is very difficult, right? It can be anything. There might be among 20,000 of the data that we are having, there might be like two clusters can be formed from the data. That can be situation where three clusters are forming, or even there can be situation where 5 to 8 clusters are also forming, right? So how to get this k value? What is the best specific way that by which we can try and understand that how this k value is being calculated? So elbow method is a kind of solution to it. Okay.
Yes, ma'am.
So elbow method is a kind of solution to it. So why we need elbow method? The basic questions that comes into play, right? So in case of K means, we have already seen all of this, like how we are taking into clusters and how many clusters are taking. So in that form, like we are not getting the exact value of the cluster, we are just assuming. There might be situation where in a cluster we are getting the value of two different, suppose we are taking like from this, just a minute, from this data you can see that here there is an elephant camel, and cow. This data has been given to the model, right? Now, if I am doing k means, I need to initiate the value of k, right? So, suppose I am taking the value of k I am taking k value I am taking to be 2. That is the minimum that we can take, right? So k value I am taking. So there might be scenario that suppose I get a cluster of elephant and I do get a clusters of this cow and camel altogether. So they are actually not a cluster, right? They have different properties. They should be there in different clusters or different groups. So cow and camel, there is a huge difference. Camel stays in desert. Cow stays in our our domestic here and there where we are actually staying in the locality. There cow stays. Cow can't stay in a desert. And what properties the camel is having? Like cow doesn't can't possess those features or capabilities, right? So it is like we are getting this clusters we are getting. So actually, what output we are getting from this cluster, that is not specific. Like that is not the exact, that is not the perfect value. Since we have taken the value of k. Now, if we have taken the value of k equals to 3, so then there might be situation, let me take it blue. There might be situation that we get three different clusters like this, and like this, right? So if we have taken the value of k equals to 3, then we get the result to be more accurate, right? So the value of k does depend on like the value of k with the value of k, what we are choosing is depending on the result that we are getting. So it is not independent of the output. So what is k is actually dependent on the output. It is proportional, or we can say it is dependent on the output. Fine, understood what I am telling?
Yes,
Clear,
Yes,
ma'am.
guys?
ma'am.
So that is the exact reason that we need to take into account the value of k specifically very well. So this is the reason we are taking into account the value of k seriously. That's why we are needing this elbow method. Okay. So this is the reason we can take into action. Now here we have actually discussed about if we take the value of k to be small, but there might be a scenario where we are actually getting the value of k to be large, right? So if the value of k, suppose I have taken to be 4 or 5, suppose for this data, I have taken the value of k to be 5. So what will happen? So too many clusters will form, and the similar data will be like split in an unnecessary format. Like suppose this data might come together, or this data similarly, like let me take another color, maybe yellow. So this data will form. This might form a cluster. This elephant will singly form another cluster. This camel and cow might form a cluster, and camel separately might form a cluster, and cows might separately form a cluster if we put this data to the machine and set the value of k to be 5. So it's not possible we can take the value of k to be lower than what it is and also higher than what it is. In each of the problem, we will get the in each of the decision that we are taking for the value of k, we will face problem, right? So that's why we need to pick a good k value in a visualization format also, or in an exact format also, so that we can take into account. So understood what I told, what problem we will face. We take the value of k lower, and if we take the value of k to be higher, then what exactly is required?
Yes, ma'am.
Yes,
Everyone?
ma'am.
Yes, ma'am.
Okay, great.
Yes, ma'am.
So
Yes, ma'am.
fine, great. So here we will be taking like elbow method gives us a visual representation. What it does, it gives a visual representation. Okay, so this is the reason. These are the reason why we need why we are actually needing this k means. Sorry, okay, this elbow method to calculate the value of k, right? So now we need to check for the values that is sum squared error, inertia, and the elbow point. This thing we need to understand before we want to go before we want to go ahead and split it plot it down in the collab and want to figure it out how exactly the values are looking and how exactly we need to check for, right? So for that we need to get into the through for the key concept like the sum squared error, that is SSE. Like just a minute, let me write it down where I have written. Yes. So the key points, we can think it like that. Key points for elbow method, that is first one, what it is? It is SSE, that is sum squared error. Next is inertia, and the third one is elbow point. That is the most vital part to check on. Okay. So what is SSE? That is sum squared error. It what it measures SSE, the total distance, like the total distance between the data point and the center of each of the clusters. Okay, so what is the distance? What is the distance between each of the data points? So suppose let me just show you. Let me just show you here. Suppose we are having this space and we are having this space. Okay, and this are the points. Just a minute. Suppose these are the points that is taking. So we these are the points that we are taking into consideration. Okay, these are the points, and let me just make some of it so that we can get it a bit closer view. Just a moment. Okay, so now what it takes SSE, what it is calculating the total distance between each of the data points. Suppose let me just draw it down. So suppose this data point to this data point, what is the distance it is calculating? From this data point to suppose this data point, what exactly is the distance? From this data point to this data point, what is the distance? So it is calculating this. Okay. So let me just clear it. Right. So now what actually it is doing, suppose this is how it is getting calculated between the data points. Okay, so now suppose we have created the clusters. So we have got two different clusters. So this is the cluster that we have uh, taken, and this is another cluster that we have taken. Okay, so these are the two clusters that we have got. Now there is, suppose there is a centroid. This is the center and the centroid part for these two clusters. And what SSE actually does, it actually measures the distance between two different clusters and the that is the center of the cluster. From the center of the clusters, what is the distance that actually the SSE is also calculating. Understood what SSE is actually calculating?
Yes, ma'am.
Okay. So what
Yes, ma'am.
happened? We okay. So what happens when we are getting the lower SSE? What we can take into count from that lower SSE value? So lower SSE means low, like the data points that are there that are closer to the cluster centers, right? That is, we have got a better clustering, right? So if this data, this value, this SSE value, like the length is less, then we are getting the that the points are more closer, the clusters are more closer, and eventually we are getting like the data points are closer to the cluster points, right? The cluster centers we are getting into count, and eventually they are getting the better clustering. Okay, that exactly what SSE is doing. So what inertia is doing, it is actually same as SSE, but it says how compact the clusters are. So how compact, like how many data points are that, and how compactly arranged the clusters are, and what is the distance between the two different clusters that we are taking into count. Okay, got it? Then what is the elbow method? Elbow method, the elbow point. What elbow point is? Elbow point is actually a point where adding more clusters doesn't reduce the SSE value smoothly. Like suppose, let me just give you a form. Like we have got the value, and now the SSE value we are getting like this. And major drops, suppose let me change it to black. So these are the points. These are the points that we are taking. Got it? So these are actually the points that we are taking into count. Now see, from this point, suppose this point range is around 500. Okay, this point range is 400. It is 4, okay, 400. This point is suppose 300. And this point is suppose 0. Here what we are getting for this point, suppose it is 10, 20, in this range, suppose. Okay. So what we are taking when we are getting this value, so we are getting the value to be higher. This bar is more. The peak of this bar is more. Next, we are calculating for this point. There is a sharp decrease in this point, right? There is again sharp decrease in this point. Again, if we are checking, there is a decrease. But from here onwards, there is no sharp decrease. We are getting a stagnant line. Like the decrease or the difference between between these 2 points, this two range is not much. But the difference from this to this this range is more. Right? Understood what I told?
Yes, ma'am.
Yes, ma'am.
So what we need to look?
Yes, ma'am.
What, so what we need to look? We need to look at the bend. We need to look at this bend. So hope you understand. Yesterday when we studied, when I told that is when k value we have taken to be 2, we are getting the centroid C1 and C2 we are initially taking. Then we are getting the new value of we are getting the new value. Suppose let me tell it at C11 and C12 we are getting. This is the way we are repeating, but there is a stage where we are getting, that is suppose C12 we are getting and C22 we are getting, but the value of C12 and C11 was equal, right? Then we just stop our processing. This iteration is getting stopped by then, right? Understood what I am telling,
Yes, ma'am.
guys?
Yes,
Are you
ma'am.
not understanding what I am trying to say?
Got it, ma'am.
Tell sure, right? Because you people are not responding.
Hello,
Fine.
ma'am. Can you explain? Hello?
What to yeah,
This is elbow methods
yes.
because we don't know, okay, where to stop at which point. How to calculate the distance from farthest point here?
I told you, like we studied K-means yesterday, right? Aren't you there in the session yesterday? I was talking about the centroids. Aren't you
No,
not
ma'am,
there
I
in the
wasn't.
session?
No,
You
ma'am, I
wasn't
wasn't
there.
there.
So
Yeah,
that's
ma'am.
why you are not understanding. You need to look at the video, like the recorded session, then you'll be able to understand what centroids I am talking of. Okay,
Okay.
now it is not possible to repeat the entire thing, right? Because we have already studied yesterday. So you just keep a look on the recording. If still you are
Okay,
facing
ma'am.
any issue, I will help you to connect. Fine. So similarly, we are calculating the centroid, and there we are getting a point where we are actually getting the equal values. So similarly, it the similar kind of scenario is happening over here. When we are getting the value, this difference is not much. It is quite equal. And there is a sharp drop at that point, we are taking that value. That suppose there we are taking the value as 4. In that point, we are just going ahead and choosing for the value as choosing that value as the value of k. So we'll see the code there. We will be understanding. Fine. So for taking into the code, how let me just go ahead and see what are the points that we need to take into consideration while we want to go ahead with the coding part. Just a minute. Okay. So what are the steps we need to follow? For the steps that we need to follow, the very first step that we need to follow, we need to choose the range. K range in k means while we have taken into consideration, we have taken the value of k directly to 2, right? In yesterday's problem. But here we won't be initializing it. We will be just taking a range. Okay, we'll take a range where we will just take the value of k from suppose 1 to 10, let me say. In that form, we will be taking the value of k. We will take a range and will iterate in between for getting the value. Okay, so now what we'll be doing the next step? Next step is for each value of k, we need to run the k means cluster. Okay, for suppose when the value of k, how we need to run the k mean cluster, how it is getting done. Okay, so that we need to check, and also we need to compute the SSE and inertia. That we also need to check in through. Okay, so after the second step, what we need to do? We need to store the k value for the corresponding SSE value. So suppose we run it for when k equals to 2 and we got the SSE value, suppose 23.78. Suppose we got it like that. So in the third stage, what we will be doing? We will be storing. We have to store the k value for k value 2. Sorry, for k value 2, we got the value of SSE as 23.78. This we need to do when we will be doing the coding. Fourth point, what we need to do? We need to plot it down. We need to plot the value. Okay, so along x-axis and y-axis, we will be taking the value. So what we can take? So along x-axis, we can take the value of k, and along y, we can take the SSE. Okay, so for after we are done with the plot, we need to look for the elbow point. Just a minute. Look for elbow point. And once it's done, we need to choose the elbow point. We need to choose. Fine. Understood what I told? The steps are clear,
Yes,
guys?
ma'am.
Okay, fine. So
Yes,
we'll
ma'am.
just run the code. Let us just run the code. Let me just open the collab. Is my screen stuck for you? Can you just tell me?
Yes, ma'am. We can just
Yes,
see
ma'am.
the word file.
Okay, okay, just a minute. Now, like, are you people able to like see?
Yes, ma'am.
Yes, ma'am.
Okay, fine, fine, got it, fine. Okay, we'll open a collab, new notebook. Just a minute. Okay, so what we'll be doing? We'll doing elbow method. Elbow method we'll be doing. Okay, so for that, the first step is importing libraries, right? So we'll write it like that. Step one, im importing. Visible, right, guys? My collab file is visible to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
fine.
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
It is
Okay,
perfectly
great.
visible.
Okay, so we'll do importing. What we need to import, we'll import matplotlib. So all of this will be importing because cluster import, we need to import the k-means. Along with that, we'll be importing one more thing, that is from sklearn dot data set. We want to import, what we want to import? Make blobs. Okay. So what is the reason of doing it? Can anyone say? Okay. So I don't want to take any proper data set. So I have used taken imported make blobs because it will help me to generate simple sample data. Okay. It will help me to generate some of the simple data. That's why I have taken it down. Fine. Now the next step, what would be the next step? Step two, what it would be? So second step, I need to create the sample data, right? So for creating the sample data, we'll take X, we'll take Y, and we'll take make blobs. Yes, for let me just do it, but I want to change it. Suppose I don't want to go ahead for 500, I want to go for 300, and clusters and features may not, I don't want to take into account because I want to go for the k-means, like for k-means with the elbow method, I don't want to take into account. Center, suppose port, it's fine. Now cluster deviation, suppose I don't want to take it to that much, I want to just reduce it. So let me take 0.60 and the random state, let me take as 0 only. Right? So you understood what actually I do up here? Guys, understood?
Yes, ma'am.
Yes, ma'am.
So,
Yes, ma'am.
Yes, ma'am.
so who have understood, explain that what I did in creating the sample data.
We created X and Y axis and we have given the samples 300 which have centers 4 and clustered standard is 0.60 and random state is 0.
Okay, so why I have kept the random state as 0?
It helps in taking so the data remains same after every time processing. It doesn't
Hmm.
change with the
Right.
new processing.
Exactly, right. And X and Y, I haven't created X and Y axis. I have taken two different features. Yes, that will take into X and Y axis later, but X, I have taken the features of the data based on the based on the forms I have taken into down, like for the X quadrant and Y quadrant specifically, and X and Y, we have taken the features along with that, and Y actually is the output, that is the true labels that we don't want to use up here. Okay, so that's why we have created it like that. Now, what is the need? We need to prepare the SSE. So see here what we have taken. So after we have we have to create this, but we have to take the value of SSE. So when we will be calculating the SSE, we need to store the SSE value, right? So we need to store the SSE value somewhere. So the third step will take into count with the third step. So we need to store SSE. Just a minute. So we'll store SSE. So we'll be storing SSE uh, in this form. So after that, what we'll be doing, we will be take the value of k, what we have taken into count. Sorry, just a minute. Here, what we have to take a range of the value from this, and we need to work. So we'll be using for loop for that. So for that, step 4. Step 4 that we need to check. So for that, what we'll be doing, we'll be using a for loop. So we'll be using for k in range. Yes, it is like that. In this form only, we'll be checking it through. And I don't want to take this init value. I don't want to make it like, I just want it to be very simple. I don't want to take it. Right? So I just take the n clusters. What we have taken the n clusters. We have actually created the k-means model up here. What we are doing, we are creating the k-means model here. We are fitting dot fit x. That is, with x, we are just fitting the data up here, like fitting model on data actually. Then we are what we are doing, SSE dot append, like whatever be the SSE value we are getting, we are appending up here, like we are storing the value up here. Okay, so this is the way we are just storing the SSE or the inertia in a form. So this is done. So now what is the last step? That is to plot. Okay, so plotting purpose, we will be using plot, that we'll be putting in the range. Yes, yeah, we can do it like that. We can use the number of clusters. SSC, we need to uh, increase the square up the bracket up. And here for SSC, we can use the mark. Without the marker, we won't be able to get the points. So let me add the marker. Let me put it like this. Sorry, we have to keep the single bracket, right? Yeah. Yeah. So we'll created the title, the elbow method, the X label has been created, that is the number of clusters, the plot Y label, that is the SSE. Now we need to put plot X, like the X tricks we need to put, just a minute, plot dot. Yes, I want to put it like this, and I don't want 1 because our range is 11 to 1 to 11. In this format, I want to do it. Now let me try and run this. So it is taking a bit time to run. Let's see what happened. Name plot is not defined. Okay, I haven't PLT. Okay, I have used PLT. Okay. So it has got, uh, I have got the elbow method, right? So see what, this is how we are going ahead with the elbow method. So along this y-axis, SSE has been printed. Along x-axis, the number of clusters has been printed. And this is the point. Like this actually is the point where we are getting in through. See, from here to here, there is a sharp decline. From here to here, there is again a sharp decline. From this point to this point, there is a decline. But from point 4, we are not getting any such sharp decline. The value, like the difference from this point, like this SSE value, might be not that much or very minimum, right? Understood? So for this very point, we'll be considering the K value as 4. Understood?
Yes, ma'am.
Yes,
So
ma'am.
Yes, ma'am.
everyone clear?
Yes, ma'am.
Yes, ma'am. Yes. Now it's
Okay,
understood.
okay,
Yes,
Yes,
ma'am.
ma'am.
okay, fine, great. So we'll just go ahead
The curve
and
is
we'll,
looking like an elbow.
sorry,
The curve is looking like an elbow.
I'm not getting.
I'm saying the curve is looking like an elbow.
Yeah, okay, that's why it has been named as an elbow method. That is the exact reason
Yes.
we call it as elbow method. Because there is, previously there is a huge decline that we can see the value of SSC, and suddenly we got it through, and where the values are, there is no such sharp decline that we are taking into account. Okay, so now we'll see for the code for k-means. K-means has already been taken. Now we'll just see the value of k-min. Okay, so it will be similar likewise, but some point will be different. So let's just take in through. Suppose let me just take this value like this, copy it down. We'll just do it in the code section. This part, let us just take it common, and for this clusters, here I don't want to take it in this way. I have suppose taken 300. Now we'll just take the center will be taking 4, since we have taken the value 4. Now this I don't want, and the random state I will be checking for suppose 42, let me keep. Fine. So now what we'll be doing, I don't want this SSE part. Now what we'll be doing, we will be visualizing the data before clustering. Okay. So this is the thing that we need to do. We will be visualizing the data. Suppose step 3, that is visualizing data before clustering. Okay, so where we are doing PLT, we would be using the scatter, we'll take X, we'll put the value in the form like this, comma 0, we'll be putting it down. Now we'll be putting till X value till 1, and now we want to put the value of S. 50 that we have taken it down. Now we will be adding the title and show. Before clustering we have put, now what we'll be doing, applying k-means. Fine. In case of applying k-means, the similar format will be using whatever where it is. Okay, we'll be taking the data up here. Since we have taken it like that, we'll just take it in this format. Now we need to fix this. Okay, so K means we have taken the clusters values. Suppose we have taken here, there is no point. We have already taken the elbow method. We know the value of K. We have will take it as 4, and now the random state we can take before previously we have taken 42. We'll keep it as 42. Now what we'll be doing? We have fitted uh, on the data. We have fitted the model. Now what we need to do? We need to get the cluster centers. Fine. So in case of cluster centers, what we'll be doing? We'll be putting centers, then we'll be putting k-means into cluster center. Yes, this we need to do. And I don't want to print it down. I don't want to print it. I want to make it labels. I want to make labels. Create a value that is labels. K-means labels. Now, here I want to visualize. Visualize after clustering. Yes, we can keep it like that for K0, C labels and C map varies, and we want to put S equal to suppose 50. Let me put. Now we'll be doing, going ahead, what we'll be doing, we will be putting the scattered as well. Yes, we'll be doing the same. That is data after like the claiming after it's been done with the clustering that we will be doing. And we have put the centers. We want to black, okay, fine, not an issue. We want to set S, okay, and I don't want this alpha. I want to mark. I want to marker the value. I need a marker that would be equal to X. We could put it X so that I get the center marked. Okay, and we'll just try and run the code. So what is the argument S? Okay, okay, got it. This will come. So let's. The argument repeated S. What is the issue? S equal to 50. Yeah, we can take it. Okay, we can just remove it also, not an issue. Fine. So we have just visualized it before the clustering, how we have taken it down. So the clusters was like this before, and after the clustering, this all have become initial or individual clusters they have become. And the centroid has been marked with X. Understood how we are just going ahead and running the codes for we have done the elbow method, then we have done the k-means. So k-means before clustering, we have viewed the point, how the points are. Since we have just taken it in a random, like we have taken you like make use of make blobs. So that's why we have got the data like this. Suppose in any of the real-time data, we won't be getting the data in this way, right? We'll be getting in a different format, suppose. So then after clustering, we will be getting it in this format, like different clusters has been made out of this data, and we have got the centroid, like the center of each of the clusters. Clear? Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. It's
Yes,
clear.
ma'am.
So everything is clear, right?
Yes, ma'am.
Up to now?
Yes,
Up to
ma'am.
now, everything
Yes,
is
ma'am.
clear, right?
Clear.
Yes,
Fine.
ma'am.
So great. So we'll just move ahead with the hierarchical clustering. So this is actually the form of hierarchical clustering. So we'll see one by one what hierarchical clustering is done. So see here actually what we are having in case of clustering model, we have here k-means, we have hierarchical clustering, will be, we have DB scan, we have mean shift. Along with that, we have all of this, right? So initially, like easily, we are trying to say and see to it. Okay, what is class like hierarchical clustering? First, we'll check into that. So what actually is a hierarchical clustering? It is a, in simple word or in any word, we can say it is a unsupervised machine learning. But that exactly not the update what we get from that. So what exactly is hierarchical clustering? It is used to group similar data points into clusters based on what? Based on how close they are from each other. Okay, so this exactly we already did in k-means, but what exactly is the difference? So in case of k-means, where we what we did, we actually fixed the number of clusters, right? In case of k, we have taken the value of clusters, we have initialized the value of the value of k to be 2, right? In any of the problem, we have taken the value of k to be true. Sorry, to be 2. Okay. So now in this case of hierarchical clustering, we don't need to decide the number of cluster beforehand. In k means we used to keep the value of k to be 2 from beforehand, like based on the data that we are having. But here in case of hierarchical clustering, there is no need to put the value, like the put the value of k decided from the very first stage. Okay. So what it creates? It creates a tree-like structure that is called dendrogram, so which shows how the points are merged step by step. Okay. So see, this is dendrogram actually. So how it has formed the structure of a tree-like structure, like uh, here two branch came up, in two branch there are two values. Against this value we are getting this. So this is how we are in case of hierarchical clustering. It creates a tree-like structure that we call it as dendrogram, and it shows how points are merged step by step. Like from this point how are we are getting this point, how this point are getting, how, in what format we are getting this points, that will be that we are actually getting into through. Okay, so initially let me just tell you some of the details, then we'll move ahead, so that we'll just keep that thing in mind, so that we need to cover that. Fine. So types, in base of types of hierarchical, there are two types. First one is agglomerative. So anyone know about agglomerative? Guys, anyone?
Yes, ma'am.
Okay.
At the
Yeah.
starting of our data, it's like group into single set of data, and then it's segregate into the other sets of data, like group based on similarity in the data set that we have.
Yeah. Actually, kind of like it is not like a group. We are repeatedly merging the two closest set, like the closest clusters you can say, to create into one. So from single, we are getting the group. From single, we are taking into consideration, and eventually we are making the group. We are continuing this process. We keep this merging process on until we are getting a big cluster. So from single step, we are getting into a big chunk. And the one that you are telling from a chunk, we are dividing, that is
This
divisive. That is top down.
this
Divisive.
divisive clustering. Yeah, that is.
Yeah. So this one is agglomerative, that is bottom up approach. We also say it like that. Fine. And the next one is divisive.
That is take a top-down approach.
Yes, that is top down approach, right? Fine. So we'll just look into that form as well, and how this agglomerative hierarchical clusters actually work. That will also take into consideration, and eventually we'll move ahead. But before that, we need to understand this dendrogram. So what actually happens in case of hierarchical model in a pictorial form, you can say like it is an unsupervised learning that group data into three. So this is the form. It is actually dendrogram. So what it happens? So first there is single points. So in case of this are actually this one, this papaya, this is this pineapple. Each of the fruit is different up here. So each of this point is different. From each of the point, we are seeing the similarities, and based on that, two different group fruits are grouping together into a clusters, and from we are forming different clusters first based on the structure and the features, and after that we are merging the clusters. This actually we are doing in case of hierarchical clustering. So this much is clear, guys. This much is clear.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Sure,
ma'am.
understood.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, just a moment please. Okay, fine. So we'll just move ahead with dendrograms. So what dendrograms is? It is a like this is the special kind of diagrams that you can see that looks like a tree. You can see this is actually looking like a tree. So it shows how data points or the clusters are grouped in step-by-step format. Okay, in step-by-step format, how the hierarchical structure are actually forming. Okay, so what is the purpose of working with this and working with dendrograms? Actually, we want to visualize how the clusters are actually forming. The step-by-step process of forming a big chunk of cluster that we want to see from scratch. That is the reason we are working with this dendrograms. Okay, so why dendrograms is used? Because it helps us to understand what it helps us to understand. It helps us to understand the similarities and the dissimilarities that are there in between the data points. Suppose these are the data points, so there must be some of the reasons that's why this fruits are taken into one single clusters. These are the two different points. There might be some, at least some reason why they have been taken into a specific clusters, and there must be at least some reason why they have taken into clusters. Apparently, if we are looking, we can see this papaya and this what it called pineapple. This are the color wise it is same, so we can just put it all together. And here also all the fruits are red. That's why they have grouped it together. So we can see, suppose if we can think it of, these are similar in terms of color, but here we are seeing the difference in the color palette as well, right? So that's why we have, maybe they have grouped it based on the similarity, and they have grouped out based on the dissimilarity, right? So that what it does, it helps us to understand how similar and dissimilar the points are. Okay, it helps us, what dendrograms do, it helps us to decide the number of clusters in the data point. Actually, because in case of k means, we actually doing the value of, when getting the value of k means, priorly we are deciding it and then going for the k means. Here there is no point of choosing the value of clusters. They will do it automatically. Okay, so it also shows the order in which the clusters is getting merged, right? So it also shows us the order in which the clusters is getting merged. So we got to see the level 1, got to see the level 2, got to see the level 3, right? Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
Yes,
so
ma'am.
we'll see. Okay, great. So we'll just see in step-by-step format. Just a minute. How let how it actually came into place. Okay, so in a step-by-step format, if we can think, so first we need to start with the data points. Like we need to start with individual data point first. So here you have first see there are individual points or individual data points that we have taken into account. So first is the individual data points. Right. Fine. So suppose I can take the points to be as A, B, C, and D. Just for a reference, I am saying. So we will start with each as its own cluster. Okay. Each as its own cluster. Fine. So suppose we are taking it as A. So we can write it down as A as a separate cluster. Then suppose B as a separate cluster. Then suppose we are taking it as C as a separate cluster. Now we are moving ahead with D. So we have got how many clusters are here? Number of clusters. Tell number of clusters individual.
4.
4, right. Yes, exactly. So initially we have based of individual points, we have got no 4 clusters. Fine. So next, what does the algorithm says? What it does, we need to calculate the distance between the points. What is the distance between the points that we need to calculate? Distance between the points that we need to calculate. So how we will be doing it? We'll be using Euclidean distance. Okay. We'll be using Euclidean distance to do that. So what we will be doing? We will be taking into account A and B. Now A and C. Now A and D. Right? So for A it's done. Now it will be seeing for B and D. Sorry, B and C. And it will check for C. Sorry, B and D it will check. And lastly, it will check for C and D. The distance between all of them, it will be checking. Fine. So now what it will be taking after the distance has been calculated. So it will just a moment. So for the third step, it will do the two closest points. What like suppose there is a point where A and B are the closest. Okay. So they will merge it together. Okay. Suppose A and B will get merged together. So this happens. Suppose these two data points are there, and between them, the distance between these two data points are closest or the smallest. That's why they have been segregated, like they has been put into a single cluster and they have merged together. Fine. Now the step will continue. This is for the first one. Next, the step will again continue. The process will continue. Then next, AB will check for other points. It will check for other points. Now we came up, suppose C. This point was closer. Then what it will do? It will merge C also with it. Okay. A plus B plus C. Okay. So this is how we are getting the points. So this is how from initially we have taken into from single clusters. Now we have taken it. This is the stage 2. Just a minute. This is stage 2. This one stage 1. So between the like when we are taking it with the distance, we got across suppose A and B are closer. So we are merging it down. Then the next step is we are again calculating and seeing it through. Then we are finding C is closer. So we are merging C. So this is stage 3. Okay. So this is how we get finally all the points will be merged into a single big chunk or a cluster. Fine, understood?
Yes, ma'am.
Yes, ma'am.
Sorry? Okay, everyone understood, right?
Yes, ma'am.
Okay,
Yes,
so let
ma'am.
me just give you
Yes, ma'am.
this points. Okay, so see, this is the visualization of dendrogram, how actually dendrogram looks. So what this horizontal line, these are the horizontal lines, right? So what it represents? It represents that merging has been done. First initial stage, we have taken into account P and Q. P and Q has been merged. That's why we have taken this line. Then after the merging of PQ, this PQ has been merged with this. Like then this part has came up, TQ, this has been merged. When TQ has already merged, S has merged with it, and then R has merged with it. So in total, we have got it. So this part, this horizontal line, this represent the merging operation that A plus B we did, right? So we are merging. So here we are merging it. Okay. And what this height of the line or this vertical line do? This shows the distance. What actually is the distance from one point to another? That it actually shows like the difference. So the shorter line, it represents the similarity that is there in the clusters. So more the shorter line, there will be more like more clusters will be there, and this horizon like this vertical line, these are less similar. Like more like taller lines will be there, or this vertical lines will be there. There will be less similar clusters. Okay, understood,
Yes, ma'am.
right? So we'll just go ahead with this agglomerative part. So how much time we are having? Okay, so we can try and do this agglomerative at least so that it becomes easier for us to calculate for this divisive one, and thereby any of this hierarchical or tree-based problem that we have enlisted, we can work it easily. Like any of this will be make easier if we want and go ahead and learn any one of them, right? So we'll just see how this agglomerative hierarchical clustering works. So we'll take into a step-by-step format. Okay, just a moment, please. So this is the similar way like this I actually explained. This is the kind of agglomerative hierarchical form only. So we'll start with the individual clusters. Okay. So we'll start with this individual clusters like A, B, C, D. Then what we'll do, we'll calculate the distance between them. We have calculated this distance between them. We have gone ahead and merged suppose two clusters with this small distance, having this small distance between the clusters that we will be merging, and we will be repeating the same process there by there and will create a dendrogram, right? This is actually what I told. This is actually a form of this hierarchical agglomerative cluster only. So this is a problem. Like this is the example that we can take into count. So this is the first step, second step, third step, fourth step, fifth step. So there has been given with the fifth step. So first there are suppose I have taken till D, they have taken till F. So six D values they have taken A, B, C, D, E, F. So they have taken the value and they have segregated them accordingly. Like the each point is a each cluster. Fine, understood. So each point is each cluster. So now they have taken down the difference between each of the points from A to B, A to C. Like let me just draw it down. So they have first calculated the distance from A to B. They have calculated the distance from A to C. A to D has been calculated likewise. Next, A to E has been calculated. Again, again it has been calculated for A to F. Okay, so this one for B also it has calculated C, D, E, F for everyone it has calculated. Then after that they have compared the value, the distance value they have compared. Suppose for B and C they have got the closeness, the most closest one. So they had been segregated and merged together to form D plus C. Fine. Similarly, D and E, when they have checked, we have checked the distance, individual distance has been checked on. We got they have the least distance, like the distance that between them is least. So we have just merged them and formed D plus E. Okay. Now in the second step, this is we are done with this first step. Second step, we are doing with this two. So when we are doing it with this two along with this, we are getting, suppose for D and for D, we are getting this DE is getting close to this F value. This F value is getting close to its DE. So we are merging with this F value. Okay, understood? Guys, understood?
Yes, ma'am. Understood.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
So,
ma'am.
so after merging this BE also, we are going ahead and seeing this DEF is getting closer with BE. So we are merging it all together. Okay. And when we are checking this point with this point, we are checking that they are also
Ma'am.
very close. So we are just merging it all together. So from single data points, we are getting into a big chunk cluster. Understood?
Yes, ma'am.
Yes.
Okay, fine. Great. So now let me just open the collab file and see
Yes,
how
ma'am.
we can just put in through and work with this, how we can plot this agglomerative that we need to check. Just a moment, it is opening. Screen is visible?
Yes, ma'am.
Okay, fine,
Yes,
great.
ma'am.
So we'll just see how we can work with this agglomerative part. Okay. Here you can see first hierarchical agglomerative clustering. So how we are doing it? First, we are going ahead importing the files that we need to take into consideration that we have actually done, right? So after doing it, what we did after doing it, we are going ahead and defining the data points. What are the data points that we want to take into consideration that we are doing it? Here we are taking the 2D NumPy array. Okay, so for that we are using this 2D NumPy array and here we are defining the data points. Okay, so that what it signifies for X it is 1, for Y it is 2. So in this form it is actually getting segregated. Now what we need to do, what we need to create the agglomerative clustering problem. So we have to do the modeling. We need to do the modeling. So how much cluster we want to put in, we can try and put in 2, and then we want to go ahead, like we want to go ahead and we want to like define the matrix actually in what matrix it will be getting and dividing. Okay, so we want to put it like that. We want to measure the distance using Euclidean. Fine. So we want to put it with Euclidean. Then what we did the linkage. In what format? This linkage part we will be studying. So as of now, take it like that, but we will be studying henceforth. So this linkage, what it actually does, it performs a hierarchical clustering in the data of X, the X value that we have taken into consideration. This linkage is doing here, and what is a method of calculation? Okay, this word is a method of calculation. So just a moment. Let me just show you if I have put it down here. Yes. So this is how the clusters actually form in case of what? So in case of mean, this is how the clusters are actually formed. In case of words method, this is how the clusters are formed. We will be studying them, don't worry. So we need to put this in what format I want the linkage. Now in the third step, what we are doing, we are fitting the model. We have fitted the model accordingly, and now we want to visualize the cluster, how the clusters actually is forming. Okay, so see, this is how the clusters are actually forming. So this is how we want to create this agglomerative form. Understood? Like, did you understood how we are doing it in collab?
Yes, ma'am.
Everything is understand, like everything you understood as of now, whatever has been explained. Sorry, did anyone told anything?
No, ma'am.
Understood, right, everyone? Okay, fine. We'll just move ahead with hierarchical divisive clustering. Okay, so we'll just check on that part. So what is hierarchical divisive clustering? So we'll just see how it actually it is. So initially what we did, we just started from 1 and gone ahead to point 0.5. And in case of like hierarchical divisive part, we just do the opposite of agglomerative. Instead of starting with each of the point as its own cluster, we just start off with like we just start off in a different format. We start with all the data, that is the big cluster chunk that we actually this like we started from here. We started from the exact big chunk that we take into consideration. Then we just split it down. Okay. So in case of divisive, we take the big chunk, then we just split it down. Okay. So next, what we can try and do, we can just go ahead and with the code part how we can do this one. So here the similar way, this is k-means or what? Like divisive clustering, first split, yes. This is the one. So how we can do it? I have just imported NumPy. Then I have gone ahead for Matplotlib for plotting it down. So we have imported the k-means clustering because clustering would be required in that case because from the cluster initially we need a cluster. From there we are actually splitting it down. So that actually is the point. That's why we are doing it like that. We are using the k-means and then putting it down. So here we have just taken into consideration of the data that we want to take. We have taken the 2D NumPy array and we have like taken down the data here. Now we start with all of the data. We have actually taken it as two clusters. We have taken two clusters, like we split into two exact clusters and we want to randomize that is for 42, like so that we stay consistent. The results stay consistent. That's why. Okay. So next we have just gone ahead with labeling part. We have just trained the model, like we have got the labels part. So whatever be the values or data in the X, we will get it labeled. So labels will contain either 0 or 1 because it depends on the cluster that belongs to the point. In that format, it will go ahead and will just plot the form. So see, this is how it has actually formed. So here what it has, this yellow points that you have taken into consideration, that was in a single line because we have clustered them into two different segregations. So and here you can see the difference, how the difference has been taken into consideration. So understood?
Yes, ma'am.
So
Yes, ma'am.
how we do it? How we do it? We start with a big cluster that is all point. Then what we need to do? We need to split the cluster into further by like one of the most of the points that are there. We need to split it down. So we need to apply the k-means with two clusters to get the selected clusters, and we need to repeat it until we get the desired number of clusters in its own clustered form, right? So this is how we are actually doing it. Clear, guys? Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So we'll just see about DB scan. Because if we go ahead with this part now, understanding this matrix comparison, this part now, it will take long and it won't get completed in the time frame that we actually have. So we'll go ahead with DB scan. Okay, what DB scan actually is? So DB scan stands for density based. spatial clustering of applications actually with noise, of application with noise. N stands for noise. Okay, so what is the main idea or how we can think it of in case of DB scan? So instead of deciding the number of clusters that we do in k means, it forms the cluster based on the density, based on the density of the points, like how dense, like how we can say the how dense the data points are grouped together. Okay, how dense the data points are, in that format they are grouped together. So here we are taking into consideration about the density factor. Okay, so it tries to find what it tries to find, it tries to find the area where where there are like lot of points close to each other. Like I have given you one example, right? Yes. So you see here the data points are more close and came into a segregated format. Like it has came like speaking to each other in this format. That's why. So it is finding those areas where there are a lot of data points that are present close to each other. So this is the area where we are getting the high density, right? And separate, we need to separate them from the low density. Like these are actually the low density points, or maybe in certain case they are counted as outliers. Okay, so we need to separate them from the areas where there are points like 1 2 points are there or low density points are there. We need to segregate from there. So that's why DB scan is doing it based on the density purpose. Okay, so what are the main points that we would need to take into consideration in case of DB scan? That is, first is epsilon, that is the distance value that defines like this, the difference, this distance actually, this distance value is measured using this epsilon. So the distance value that defines like how close 2 points must be to be considered as neighbors. Like this points, this these are actually the clusters. Okay, so you think it of as a single point. So what is the difference? So if the difference is close, like suppose this two, the difference between these two clusters, let me take a pen, otherwise it won't be able to make you understand. So these 2 points, the distance between these 2 points are close, right? That's why this point, suppose A, this point, consider this point as its neighbor. But this point and this point, the distance is more than this. So this doesn't consider as its neighbor. Understood what I told? What is epsilon? So
Yes,
this
ma'am.
is
Yes.
actually the distance. Okay, so minimum points are there. So minimum points. What minimum points? The minimum number of points that must be within this epsilon distance to put into the clusters. There must be minimum. There is a like what I can call it, a threshold value of the number of point we can try to call it out, that must be there inside a cluster, that has been considered using minimum points, that has been considered as mean point. Okay, understood. So that actually we are trying and understanding from this part. Fine. So in a step by step format, we need, if I need to think it of how we are going with DB scan. So let me just show you. Just okay, we'll see the code as well. Don't worry. So in case of DB scan, first we need to like pick up the random data points, like the data points we need to pick up. Data points we need to pick up. Next, we need to check is the point are nearby, or how well the points are there. Like the epsilon value, we need to check it through. Like is the number like how close the data points are. The epsilon part we need to check. Then what we need to check, like is the number of nearby points are greater than the minimum points, that the threshold value that we need to check if the value is greater or equal to the threshold. If yes, then we make it a core point and start with the clustering purpose. So we need to compare it with the the value, like how we can write it, like is the number of nearby points is greater or equal to the mean points, right? So we need to check with the threshold. This mean point, we're calling it as threshold. We need to check with this threshold. Okay, so if it does, then we need to continue until the point are classified. We need to continue until all of this point has been classified and clustered also. Okay, so we need to like classify in the sense like we need to check if that point is there in the cluster, in the core part, like in the center of the cluster, or in the border section, how they are actually there, or marked, or we need to mark it as a noise or outlier. Like here, you can see the data points are inside this cluster. This data points are inside this red is now considered this red point as cluster. So this data points are inside the clusters. We need to classify that if this point is inside the cluster, or what is the position of the cluster. Is it there in the core position, or it is there in the like border like this? Okay. Or now if we want to take into some points where we get the values like here, or any values like here, this points are doesn't count in any of the clusters, right? So they are actually coming under noise or outliers. Fine. Understood
Outliers.
what I told?
Yes, ma'am.
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, fine. Yeah. Great. So hopefully, as of now, like till now, what I have told to you, everything is understandable to you. Like everything you understood,
Yeah,
right?
ma'am.
Yes, ma'am.
Okay. So
Yes,
we
ma'am.
are left with this matrix comparison in this part. This part we will be covering tomorrow in tomorrow's session, and we'll try and cover this forms like this association rules, like all of this part, how we are checking it through. We are left with the mean shift for the clustering models. We'll try and go ahead with this, and majorly we will try to complete this dimensionality reduction, basically the PCA part, because that plays a very important role in case of dimensionality reduction in any of the data where we take into consideration, or any of the form that we consider upon, right? So we'll do it in tomorrow's section, and then you'll be given with the project for this week. Fine, clear, guys?
Okay.
Understood?
Okay, ma'am. Okay, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay,
Understood.
Yeah,
fine,
ma'am. Yes, ma'am.
great,
Okay.
great. Then we'll just stop today here, and we'll meet tomorrow accordingly, and we'll study accordingly. Fine. So as of
Okay, ma'am.
now, any question relevant to anything you people have? Any one of you?
No, ma'am.
Ma'am, can
Oh,
you share your notes?
that I have, like just now I have created in this Word file. This one you are asking?
Yes, ma'am.
Okay, fine. Since we will be working here only, we will be doing the tomorrow session also. Will be working in the same Word file. I'll just merge it up, and if possible, I will share with you this Word file. Because yesterday's session stuff that I have explained in the session, that I forgot to save, so that part would be missing. Fine.
Okay, ma'am.
Yeah.
Okay.
Okay, ma'am. Thank you.
Okay,
Yeah.
so tomorrow
Thank you,
we'll
ma'am.
continue in this word book, and then we'll just go ahead. If possible, I will try and share with you. Fine?
Okay, ma'am.
Okay.
Yeah,
Yeah, ma'am.
Okay, ma'am.
fine. Bye bye. Bye, guys. Bye bye.
Bye, bye, ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Bye.
Thank you,
Thank
ma'am.
you.
Bye,
Bye
ma'am.
bye.
Thank you,
Bye
ma'am.
Bye.
bye.
Thank
Yeah,
you, ma'am.
Thank
bye.
you,
Bye
ma'am.
Thank you, ma'am.
bye. Bye. Thank you. Bye bye. Guys, you can leave. The session is over.